Modern artificial intelligence has moved past the era of pure software. It now functions as a massive industrial logistics operation. To maintain its lead, Anthropic recently rented the entire 220,000 GPU capacity of SpaceX's Colossus 1 facility. Operating this site requires over 300 megawatts of electricity, the same amount of power needed for a small city. Anthropic was forced into this partnership because their API volume grew 17 times larger in a single year, completely outstripping their internal infrastructure. For the teams building the next frontier of models, access to the local power grid is now the primary constraint on growth. While data centers expand, the individual developer is facing a shrinking hardware environment. Local AI relies on specialized sealed machines that cannot be upgraded by the user. Apple recently restricted this environment further by removing the 256 and 512 gigabyte memory options from the Mac Studio, leaving a maximum of 96 gigabytes of RAM. This memory reduction happened exactly as the open-source community shifted toward larger models. A 27 billion parameter model requires significantly more than the current 96 gigabyte limit to run at full precision. Local developers are being physically locked out of the newest models, creating a race to find software workarounds for these hardware deficits. Resource starvation has changed how developers interact with models. They are now forcefully altering the base architectures of systems after they've been released. The community recently successfully grafted multi-token prediction layers onto Alibaba's Qwen 3.627B model, adding an inference speed feature the original developers chose not to ship. This graph shows the result of that hack: 200 tokens per second on consumer hardware, a 2.5x increase over the official model. Some are even experimenting with decoupled attention, splitting layers across different machines and streaming the weights over a local network to bypass memory limits. To the developer community, frontier models have transitioned from untouchable black boxes into modular engines to be dismantled for parts. Developers are using this newfound speed to run hundreds of autonomous tasks simultaneously. New tools like Superset 2.0 and Anthropic's managed agents are built specifically to orchestrate these fleets of coding agents in parallel. These agents operate in the background, defining their own success criteria and iterating through entire codebases overnight without human intervention. Hyperspeed execution allows developers to ignore traditional hardware limits, but it effectively removes human oversight from the development cycle. Deploying autonomous agents at this scale introduces immediate security risks. The bleeding llama vulnerability recently proved this, as a flaw in the Ollama model server allowed attackers to remotely siphon unauthenticated memory from 300,000 servers accessible via the internet. This vulnerability persists because of a psychological shift. Many senior engineers admit they no longer review every line of code their agents produce. Verifying thousands of lines of AI output feels like a waste of time compared to writing new prompts. By prioritizing the speed of autonomous agents over manual review, developers have turned local AI systems into a massive, unguarded attack surface. Beyond security, high-volume AI code generation carries a long-term architectural cost. Researchers documented a volume quality inverse law. As the volume of AI-generated code increases, structural integrity drops. These capable models leave a machine signature on software, producing bloated, tightly coupled architectures that become increasingly difficult for human teams to maintain. The industry is finding that while AI bypasses hardware and human speed limits, it cannot yet bypass the need for human